check this one out right now. I'm going to give you guys the fastest way to find the equation of a line given 2 points. So in all these line segments, we are given 2 points. So in this purple line, we're given that point, given that point, and those are the endpoints of the segment, 64.55 and 128.87. Now, if you have 2 points, that's enough to find an equation. So I think the easier thing out of the two for you so far is figuring out how to get a slope. Because remember, to get an equation of a line, we can get it in the form y equals mx plus b. That's pretty much the easiest form of an equation of a line to figure out at this stage of your studies here in algebra. So if we have 2 points, we need to find one, the slope of this line here in purple, and we're going to find the y-intercept of that line, because y-intercept is the b value. Slope is the m, y-intercept is the b. So as long as we can figure out what this is and then what this is, we'll be able to find an equation of this line relating x and y, how it's describing how x and y relate to one another. Now, we can figure out slope first. We're going to do that first. And then we're going to figure out what y-intercept is of this line. Notice here, the coordinates of this are all positive. So our y-intercept is when x is 0. So this is x is 128 here, x is 64, y-intercept would be way over here, right? Way over here, and it'd be hard to figure out the exact y-intercept without having a graph or without some solving, which we will do in a little bit. So step one, what I'm going to show you to find an equation of a line given 2 points is that I'm going to show you how to find the slope of this purple line right here, purple line here. So we'll call that line 1. The best way to get the slope of this line given 2 points is to use the following formula. If you notice here, we have been given 2 points with an x value and a y value, and another x value and another y value. So I can make this x2, y2, and that just means the second point. And then I can make this x1 and y1, and that just means the first point. And it doesn't matter which one's the first point, which one's the second point. We're just going to use this formula. Because this formula tells us is that in the numerator, this means change in y, because we're subtracting one y coordinate from the other y coordinate. This means change in x, because we're subtracting the corresponding x coordinate. Right? See here, this is y1 is immediately over x1, so means the first point. We're subtracting the first point's coordinates from the second point's coordinates, and this would be how much x changed by, going from point 1 to point 2. So if we do y2, and y2 is 87, and minus y1, and y1 is 55. And then we do x2, which is 128. And we subtract x2, which is 128. We subtract x1, which is 64. We can get our slope. 87 minus 55 is 32. 128 minus 64, well, that's just 64. Now, this is our slope, right? 128 minus 64. 64 is half of 128, so that's how I figured that out. But anyways, this is our slope, and we can simplify the slope because 32 goes both into 32. It goes into it once, and 32 goes into 64 twice. So we could divide, try dividing your numerator into your denominator, and if it divides perfectly, then it can simplify very simply. So 32 divided by 32 is 1, and 64 divided by 32 is 2. So this is in a 1 to 2 ratio. So our slope here is 1 over 2. This is a 1 over 2 slope for that line. Let's get the slope of the other line, line 2, in green here. We notice that this line is actually decreasing from left to right. So we anticipate that this slope of this line is going to be negative. We will make this y2, x2, and x1, y1. I like choosing my first points on the left side because remember we read graphs from left to right. So if I choose my x1, y1 from here and my x2, y2 from here, then right, I'm seeing that my decrease in y is going to be negative. It's going to be negative. So, or my change in y is going to be negative here because our y2 is 3, it looks like here. I hope I'm reading that correctly. So this is y2 is 3, right? So we're going to use this formula, y2 minus y1 over x2 minus x1. Change in y over change in x. So y2 is 3, subtract 66 from it. Set that over 95, because that's x2 minus x1 minus 86, which is good because our change in x is positive here, right? 95 minus 86, we've gone over, we've run 9, right? 95 minus 86 is 9. And 3 minus 66, ooh, that's a negative 63. Does 9 go into negative 63? Yes, it does. It goes into negative 63 negative 7 times. You can double check that on a calculator if you'd like. But m equals negative 7.
I like this.
All right, so we have an m value. We have m values for the first equation of a half, and we have an m value for the second equation, which is negative 7. That's nice because we know what this is now. We know we have an m. We still don't know what b is, and that's what we're going to do next. So we're going to do something that I've explained in a video already, but we've done a little bit less of this than we did in a typical year. But the best way to figure out what the y-intercept is, okay, we got to get the y-intercept. Next step is the y-intercept. The best way is to do something called solve for b. Okay, solve for b. Can I solve for b to get my y-intercept? And what I have written here, it says, now that you know the slope m, right, we got m here, okay? So for instance, in this purple equation here that we're dealing with, we have m, right? We're trying to get y equals mx plus b. I hope you're focused here. This is kind of the big part. We know what m is. M is a half. Now that we know that, we're actually going to have enough to figure out what b is. But not quite yet, because we need to solve for it. We actually know, in this situation, we know what x is and what y is as well. And it can be oftentimes you can forget that you actually do know this because you were given these, right? You were given this right here, an x value and a y value, for instance, here. So what you have to do in this point is to plug in a point. Plug in one of those x, y values. I'll write this in parentheses here because I mean plug in a point, x, y, right, from one of the points that you have. And this is 65 for x. This is what we'll plug in for x to our equation. And this is 55 for y. And we'll plug that in for y into our equation. So just by taking, we can do this with these if we want to. 128 for x and 87 for y, but might as well do these. These are a little bit smaller. It's 100 might be easier to work with. So if I know my slope is 1/2, I know one of my x values that works in the equation, the input of 64. Would return a y value of 55, then that's going to be enough information to determine what b has to be. What b has to be. So look what I've done here. I've done y equals mx plus b. It's just that I know that I have an x-y combination that's going to work in our equation, and I've already solved for my m. So I've done y equals mx plus b, where the only unknown, okay, the only unknown left is b, okay? So this is what we mean by solve for b. Right? Make it the only unknown because you know what an x value is, you know what a y value is that works, you know a combination that works here, and you know the slope. So you know x, you know m, you know y, you just don't know b. You're going to solve for it now. Solve for b. And I will do that now. So to solve this equation for b, we got 55 equals 1/2 times 64 plus b. Well, let's just simplify this a little bit here. This is 1/2 times 64. So that's going to be 32. And we still have this plus b hanging out here. Okay, so how do we isolate this b in this situation? If we're adding 32 to b, and that makes us equal to 55, then we just need to do the opposite. We need to take away 32 from both sides of the equation, and that will keep that equation balanced, and we will have solved for b. Minus 32. 55 minus 32 is 23, and that is our b. And we have finally gotten to what our equation is here. And our equation is y equals 1/2 x plus 23. And that is the equation of this line segment right here. When you do this for homework, you also have to say the domain in order to answer, and you write that with little squiggly marks so it works in Desmos. So you do this right next to the equation here. So you're going to write 64 is less than or equal to x, which is less than or equal to 128. And that is the information we need to graph that particular line segment over this domain interval. And that follows this path of this particular line. Let's do B. Well, let's solve for B again in line 2. So now we have this. This is our final answer. This is looking good. Same thing for B. We need to get the equation, and that's in the form y equals mx plus b. We know m is -7, but we also know x and y, one of the x and y's. So here, why don't I use this one, 95 and 3 as my x and y. So my x here is 95, and my y here is 3, and my only unknown is b. Is b here, okay? Remember, we had a point at 95, 3. That's a combination. Input of 95 gives us an output of 3, and the slope here is -7. So we just got to solve for b right now. That means we simplify this first. -7 times 95, well, -7 times 100 would be -700. It's 5 less than that, so we're going to add back to that 35. So we got -665. Again, you're always welcome to use a calculator. Plus b. Oh, that's not right. What did I do wrong here? And 95 is the x, 3 is the y, -7. Oh, yeah, this is right. Never mind. Plus b. Okay, so that's right. Now I'm going to add 665 to both sides. And I'm going to get a huge y-intercept. So this is going to be 668 equals b. So this would shoot up really, really high. See how steep this is? Really, really, really high. Our y-intercepts, remember, we got to go all the way. We go 86 over here, and it's so steep. So this is going to be a really, really high up y-intercept if we cared about the line. But we don't. We just care about that line segment. But now I have my b. Okay, now I have my b, so I need to drop it in the equation for y equals mx plus b, and I will do that right now to get the equation. which is y equals -7 x plus 668. And there you have it. There's the equation. For this one, I would also need to get my domain, and that is from 86 to 95. All right. And this solving for B thing, this will continue to be in homeworks as the year goes along. So if you don't feel like you're 100% on it now, you will still get a chance to practice this on into the future. But this is definitely the easiest way to get the y-intercept of this equation, which had such a high y-intercept. Very, very hard to set up a table and figure that out, for instance. This is how I would do it. And this one would have been a little bit easier to set up at a table, but still faster by solving for B. I'll see you guys later. Bye.